Okay, so today we're looking at lesson 9-6, area of a sector. And the learning intention is I will learn how to find the area of the sector of a circle. So let's go ahead and take a minute to get that down. All right, we're going to start by talking about the parts of a circle. And let's just start with circle in general. So circle was points around the center point. So we have a center point, and the points that go out from it are all the same distance. And that is a circle. And the way we would label it is this is going to be called circle C because it is the center point. So the way we would label it is circle C. Okay, circle C. And then the radius is simply the center point out to the circle. And then another point. This could also be a radius. So examples of a radius would be segment CD. You could have segment CB. And can anybody think of another example of a radius on this one? But you start with the center point first. So in this case, it would be CA. Very good. Okay. And diameter, if we remember, the diameter goes all the way across the circle, and it crosses through the center. So in this case, an example of a diameter would be segment AB. It starts at A and ends at D. It does go through C, but remember, when you name a segment, you just need 2 points. It has to go all the way to D. So central angle, the vertex is always the center of the circle. So the central angle would be, an example would be BCD. So angle BCD. And who can think of an example of another one? Good. BCA. Okay, BCA. Be 2 examples. Okay, and lastly, we're going to talk about a sector. And that's what we're really going over today is a sector. And if you remember last class, we briefly talked about it. And that's where it kind of said a piece of pizza, okay? And so it takes the 2 radii, so you have a radius here and a radius here, and then the points on the outside form a sector. So hence the piece of pizza look. And we label these by making an arc, and this would be B and D. And I'm kind of drawing over my line a little bit. So can anybody think of another example of a sector? Good. D to A. The B right here would be another sector. BA. So it'll be down to here. Okay? All right, and let's go ahead and take a moment. I want everybody to get their calculator out. And we're going to take a moment to make sure we remember how to find pi on our calculators. Okay, for this assignment, I recommend the little calculators called the TI-30. Okay, it's just really easy to be able to punch in the formula, and it gives us answers in terms of pi and in our approximation. Okay. All right, so let's dive into number 1. Part B says find the area of the following sectors, and it gives us a formula here. So the area of a sector, here's a formula, equals the central angle over 360 degrees. Why do you think there's 360 degrees? Yeah. Over the whole circle, right? Times pi r squared. The fraction gives the portion of the circle we're using, and the pi r squared gives the area of the whole circle. Okay, so for number 1, we're going to find the area of this sector right here. The area of this right here. Okay, so by doing that, the definition, area of sector wants the central angle. What is the degree of the central angle here? 100, very good. And we're going to put that over 360, and then we're going to times it by pi r squared. So let's all take a minute and learn how to put this in our calculator correctly. Okay, so with me, a parenthesis, and let's do 100, divided by 360, and then enclose it with a parenthesis. And then you simply just have to put pi. And then what is my radius, guys? 7. So I'm going to change this r to 7 squared. So pi 7 squared. And the first thing, some of your calculators might give it to you in terms of pi first, or it might give you the decimal. If it gives you the decimal, notice we need to round it to the nearest tenth like we were the other day. So this would be 42.7 needs to be rounded up to what, 8?
Yeah.
Okay, meters squared. And if you hit the little arrow key on the bottom, everybody do that if you got the decimal, and then it'll give it to you in terms of pi, which is 245 over 18 pi meters squared. Okay, so let's look at number 2. So number 2, we're looking at the sector. Right here, we're going to find the area of this guy right here. So area equals, what is the degree of my central angle?
180.
Very good, 180 over 360 times pi. And what is my radius this time?
3.
It is 3 because my diameter is 6, so my radius is 3. 3 squared. Oops, my page moved. All right, so let's type that in our calculator. We have parentheses 180 divided by 360 and parentheses, and then pi 3 squared. And I come up with 14.1 inches squared, and if you hit the area, or the arrow, I'm sorry, you get it in terms of pi, which is 9 over 2 pi. And then this is where I was talking about a little bit ago, where if you divided the 9 divided by 2, this would also be the same as 4.5 pi. And this is inches squared. All right, so let's look at number 3. We need to find the area of this sector, okay, right here. So on this guy, what is the degree of my central angle? How would I find that? Did it give me a degree this time? Of this right here? No? How would I find it, though? You were onto something earlier. You said a whole circle is what?
Oh, you divide it by 270?
Yeah, you don't divide, but if you know a whole circle is 360, yes, minus 270, you'll get what? I think 90, right? So technically this is a 90-degree angle. Okay? Yeah, we could have, couldn't we have? Yep. We could have. Okay, so 90 over 360 times pi. And what's my radius this time? 5 squared. So in our calculators, we have 90 divided by 360 pi 5 squared. And I come up with, I get 19.6. Is that what you guys get? Yeah. And that is centimeters squared. And in terms of pi, what do we get? 25 over 4? Yep. Over 4 pi. And if I were to divide my 25 divided by 4 out, 6.25 pi centimeters squared. Okay, so on number 4, we're going to find the area of this sector right here. And I want you guys to go ahead and try to come up with this on your own. All right, so let's look at number 4. My central angle is 30 over 360 times pi. My radius is 11 squared. And 11 squared is 121. And let's see here, if we put 121 pi. Okay, and what did we get? Okay, so for the approximate in your calculator, you would have got 31.7, okay? But when you hit the arrows in the form of pi, and notice my answer has an equal sign and there's nothing with an approximate sign. So if it's an equal sign, what actually goes up here? Whatever is in terms of pi, right? So the 121 over 12 pi, okay? And this is meters squared. So questions on that? Questions on that? Okay. So also on this, if you wanted to go ahead and take the 121 divided by the 12, this is where you would get 10.1 pi. This is what you're talking about. This or that. Either way. Okay? But we just have to make sure if it has an equal sign, that is in terms of pi. That's the main thing, okay? Okay, number 5. Looking at a diagram, it's a sprinkler, and it has a sprinkler head, it's spraying water. What is the area of the lawn covered by the sprinkler? Okay, so we have, if we notice, we have a sector here, and it's spraying our lawn. Like if it were to spray water and it's going to keep going around, okay, right? And if we're to continue the circle all the way around, you can tell it would be a circle. So this is technically the sector of the circle. Does that make sense? We're finding the area of this part? Okay, so I'm going to rewrite our formula. Area is the central angle over 360, right, times pi r squared, okay? So area equals, what is my central angle here? 145 over 360 times pi. And what is my radius? Okay, so notice if I were to make the circle all the way around, yes, you're saying, yes, 15 squares. So this would equal, if we put this in our calculators, and let me know what we get. And I should put approximation sign first.
284?
Yep,
7?
284.7. Very good. And if we check it in terms of pi, we get what? 725 over 8 pi. And this would be our feet squared. Now let's think about this. If we were actually wanting to know the area in our yard, what would make more sense for us to think about? This feet squared or this feet squared? This one? Yeah, it would, wouldn't it? Okay. So B, if the water pressures are lowered, so we're cutting back the water, the same angle, but we're cutting back the water so it's not going to spit out quite as far, right? And so the radius is being cut back from 15 now down to 7.5. Okay, so now we have the same angle, right? 145 over 360 times pi. And now what's my radius? Good, 7.5 squared. And let's see what we get. Okay, and what do we get? Anybody?
730.
Okay. I got 71 point something.
Yeah.
71.1 feet squared. Okay. And just for the fun of it, what is this in terms of pi? 725 over 32 pi feet squared. Okay. But what would make more sense to have? This guy, right? Yep. Okay. So is the total in B half of that in A? So it wants to know if this is half of A. Well, just looking at it, can we tell? What would be half of this? How would you find that out? What would be half of this?
Divide by 2?
Yeah, divide by 2. What do we get if we divide it by 2? 284. I come up with like 142 something, which is way more than this. How would I know how many more times more it is? What if we took this divided by that? So if we took 284.7 and divided it by 71.1, I'll put approximately, what do we get? 4.0 something? 0.7 divided by 1. Okay, so the answer is no. We get approximately 4.0042. So the answer is no. A is 4 times as much as B. Okay, makes sense? Okay, number 6 says, find the area of the shaded region. Round your answer to the nearest 10. Okay, so we know how to find the area of this whole thing here. So would it make sense if we found the area of that and then found the area of this and subtracted it and we're left with that? That makes sense. Cool. All right, so let's do that. So we're going to find the area of the sector by using our formula that we learned. Okay, so we want this sector, remember it's the piece of pizza. And what is our central angle here? 90, good, over 360 times pi. And what is our radius? 4, yeah, you're good. Yep, it's 4, it's this right here. 4 squared. Okay, so let's see what we come up with. And I got 4 pi. Is that what you guys got? 4 pi. Okay. So now let's go ahead and find the area. What did we say? Next of the triangle. And how would we find the area of the triangle? What is the formula for the area of the triangle? Very good. Base times height divided by 2. So what is my base of the triangle? It is 4, because if this radius is 4, every radius is 4, okay? So it's 4 times 4 divided by 2. And 4 times 4 is 16 divided by 2, so we should get, what, 8? Okay, so to find the area of the shaded area of the shaded part is going to be 4 pi minus 8. And we get like, and I need to make this a, very good, approximate, minus 8. And 4.56, if I round it right, it should be 4.6 meters squared. Okay, any questions on that? Okay, let's look at number 7. Number 7, we're doing the same thing. We're going to find the area of the shaded part. And it gives me the values right here. Okay, so once again, we're going to start with this sector, this huge piece of pizza. We're going to find the area of this. So we're going to find the area of the sector. And we do that by our central angle, which would be this, which is A. What is A? 120. Very good. So that's over 360 times pi r. What's my r here? My radius is 5. Very good. Square. So let's figure out the area of that sector. And we did the first one in terms of pi. Let's do this one in terms of pi. And if we do it in terms of pi, I get 25 over 3 pi. Okay? Okay, so let's find the area of the triangle then. And remember, what was the formula for area of the triangle? Base times height. So my base of it, if you notice, is here, because that's what's perpendicular with my height. So what's my base? It gives it to me right here. 8. What's my height? 3 divided by 2. So the area of my triangle is 12. So to find the area of the shaded part, it's simply this, 25 over 3 pi minus 12. So if we put that in our calculator, so if we put parentheses, 25 divided by 3 pi, and then minus 12. And what do we get? I get 14.2. And it doesn't give me a unit, so I'm just going to label it units squared. All right.